in A3, I can write and evaluate logarithmic functions and graph them. A logarithm to the base b of a positive number y is defined as follows. This is what we consider the exponential form. And this is the logarithmic form. Okay? So we have the exponential form and the logarithmic form. We need to get very familiar with these two forms so that you can switch them back and forth. We had a problem yesterday where we were asked to find how many years, right? How many years it would take to double our money. And we didn't have the rule of 72, and that wasn't the method that they wanted. So what we did was we graphed it, and we picked a value. So we started with $1, and we wanted to find out how long before I'd have $2. Okay? So that's what I wanted to do. All right? And so we didn't have the ability to solve this equation for x. Today we're going to learn how to take an equation we're solving for the variable, and we're going to use logarithms to solve. Okay, so if I want to take this one and write it in exponential form, solve for x. How do I write that? Exponential form. I was going to try to find a different room for you, which I didn't. Let's just move to the back there. How do I write this in exponential form? Log B, the log BB, is that what you said? The log BE,
I don't know.
I mean, are you saying B as in BE? With the log B, I got confused on.
B, E,
Okay.
E, and
We want to, see, we have this form, don't we? And we want to write it this way. So we want to take this and use this rule and write it in exponential form.
B. Would it be 6 to the third equals x?
Yeah. And what's 6 to the third? 36.
No, 36
Good. Which is 216. Now I have this. Oh, sorry. Now I have this, and I want to write it in log form. So I have exponential form. I want to write it in log form. What do I do? You have that in your notes, so I'm going to slide it down. How do I write that in log form? Log of 636? I don't think that's quite what you mean, but I think you probably wrote it correctly.
Yeah.
What's that first 6 represent that you said?
The 6 represents the base.
Okay, so it's the base, so we write it down here as a base,
Yeah.
okay? And then you said of 36
Yeah.
is equal to what? It's the 2. In this case, there are no variables, are there? They just wanted us to rewrite this in log form. And so if you took your TI Inspires, or I keep forgetting on the 84s how to change the base. There is a way, and I'll try to figure it out again, but I don't remember it right now. But if I go log base 6 of 36 and hit equals, it's going to give me 2. Okay? So in log form, 6 squared equals 36 is the same as log base 6 of 36 is equal to 2. And part of your homework today, all they want you to do is practice rewriting things, so you get familiar and comfortable with the rule. Okay? It's really important that you remember the rule. Common log. Common log is a logarithmic function with a base of 10. When you hit LOG on your calculator, that's common log. The base is understood to be 10, and it isn't shown. So in this example here, log of 100 equals 2. The base is understood to be a 10. It's understood to be a 10. We don't write it in, we understand it. The same when I do this, square root of 2. I don't write the square up in the square root, do I? The symbol's understood to be a 2 there unless I have another number there. If there's no other number there, it's understood to be a 10. Log base 10 of 100. Okay? Write in exponential form. Looks like I already did it for you. I had saved it on there. I erase it right back in. Remember, this is base 10, and the rule says the base to this power is equal to this number. Is that a true statement? Is 10 squared equal to 100? Yeah. Okay? So if we wrote this log of 100 equals 2, that's in green here, in exponential form, we would say 10 squared is equal to 100. Even though there wasn't a 10 there to begin with, in that base, there's no number there at all. It's understood to be a 10. Okay? Is that clear enough, or do we have any questions on that? Just some basics, fundamentals here we have to understand. Okay. A model to graph logarithmic functions. Y is equal to log base b of x minus h plus k. Okay. Similar to some of the things we've been doing with the exponential graphs. Okay. The base on these problems is going to influence what the shape of our graph is, but it's going to be very minor priority to me. Okay? The point HK, let's try that again. The point HK is the translation. Sorry. I started to say translation as I wrote the and I threw an A in there. The translation origin. I'm just gonna leave it that way. It's a translation of the origin. So in this case, what is my HK?
-3 and 3.
Nice. She said -3, 3. Because that's a plus, and in the model it's a minus, she recognized that H must be a negative number. Minus a negative becomes +3, right? And so that becomes a -3. So what this is saying is I'm going to move my graph my X and Y axis. Okay, they look like this. I'm going to move them to -3, 3. So the origin, instead of being here, I'm going to move it -3 and 3. So I'm going to move it to there. And so this is going to come to here. This is going to go to there. And then I'm going to graph this graph. Okay? And this is difficult. Let me. Get this out of the way. I gotta think this through, sorry. If we write this as 10 to the y is equal to x, okay? So 10 to the 0 is equal to 1. Do you agree with that? And so x is 1 and y is 0. Okay? I did have it right. It did look right. And if I put 2 in here, 10 to the second is 100, right? So if x was 100, then this is going to be 2. And if y is 1, then x is 10. Okay? And so I treat this as my new origin. And I go 1, 0, over 1, up 0. And I go over 10. So it's 3, 4, 5, 6, 7, 8, 9, 10. And up 1. And is it reasonable to suggest I go over 100? No. So my graph is going to look something like this. Okay? Now you have to be careful here, because there's no way to make this equal to 0. Okay? There's no way to make that x equal to 0. 10 to whatever power is not going to equal 0. Right? There's no way to get x to be 0. And so that's why it's not going to ever cross this line here that represents our y-axis that we moved 3 units left in this case. So it's never going to cross that line. Okay? So my graph just looks like that. And my arrow didn't look very good, but there, that's a little better. But I have to go out 90 more units before I go up another 1. And then the next one, I'd have to go out 900 more before I go up another one, because 10 to the third power is 1,000, right? So 1,000, the next one would be 1,003. Okay? So to graph these, what I want you to understand is that the basic shape is this. Okay? That's the basic shape. Now if I had a base 3, if I had log base 3 of x equals y, then my graph's going to look, my chart's going to look just a little bit different. I'm going to have 1, 3, 9 to get my 0, 1, 2. Okay? And that's 3 to the y is equal to x. Okay? 3 to the y is equal to x. And so 3 to the 0 is 1. 3 to the 1 is 3. 3 to the second is 9. 3 to the third is 27. Okay? So it's going to change my graph a little bit, but not a whole bunch. It's still going to be the basic shape. If I graph that up here in green, and say I had the same translation, well actually let's just go back to here. I'd still get this point, 1, 0, then I go 3, 1, then I go 9, 2. And so my graph would look like this. Okay? So it got a little higher, a little quicker, didn't it? Because of the smaller base. But otherwise, it's pretty much the same shape, isn't it? And if I translated it like I did this one up here, negative 3, 3, then I just take this and I'd move it over to there, and I get the same graph. Okay? So the easiest way to graph these is to look at a little chart without all this other stuff in it. Okay? And then we're going to move each of those points, in this case, 3 units left and 3 units up. So what's my translation in this graph? What's my HK values in this second graph here? 1, negative 4, good. And so that would mean I move this axis over to 1, and I move this axis down to negative 4. And so there would be my new, right here would be my new vertex. I'm sorry, my new origin. And I would treat it the same way as I did this one. And so that black graph would just move down to here. Now I'd have this point here, over 1, up 0, over 10. That's like right here, up 1. Okay, from my new origin. I'd use this table from my new origin. Okay? So again, you can make it really complicated if you want. I don't want you to. I want you to look at the equation, identify what the translation is, how far left or right, how far up or down. Draw dotted lines on your graph. You know, you start out with your original x and y axis, but then draw dotted lines where they translate to, like I did here with these lines, okay? So draw those dotted lines on your graph, and then treat this like it's the new, right here is the new origin, okay? And then use the same chart. Okay, I think that was it, but I want to do one more. Let's say I want you to practice this. Y is equal to log base 5 of x plus 1 minus 3. Okay? So I want you to graph that real quick. Excuse me. let's do this together, okay? I saw a couple mistakes in common, but almost none of them were the HK. So HK is, that's a +1, so that meant the H is a -1, and that's a -3, so K is -3. And so again, like all the other models we have, when it's inside the parentheses like that, we're using the opposite to sign. And when it's outside like this, then we use what's there. So inside said +1, so we made it -1. Outside said -3, so we used -3. So then when I draw my line, I have to go -1 and -3. Okay, so there's my new XY axis. And so I'm looking at this model. Y is equal to log base 5 of x. And if I rewrite it, that's 5 to the y is equal to x. And so 0, 1, 2. If I put 0 in for here, what's 5 to the 0? 1. Okay? And if I put 1 in here, then I get 5. And if I put 2 in here, I get 25. Well, I'm probably not going to graph this one. It's kind of far out there. But the other two I can graph pretty easily. From my new origin, I go right 1 and up none. That's this point. And then from my new origin, this is the other mistake I was seeing. People were going from this point here, 5 right and up 1. But no, go from the origin. Right 5, up 1. So it should be that point there. Okay? So it looks something like this. Okay? Now this curve down here is going to get pretty close to this new y-axis. It's going to get pretty close pretty quick. It's going to get pretty close pretty quick, but it's never going to touch it. No matter how small I make my y values, I can even go negatives. I'm going to get really close to that line, but I'm never going to get there. Okay? Okay, any questions on that? Sabrina, did I answer what your question was? Excuse me.